Next one, I want to prove that 3 plus 7 plus 11 plus 15 plus dot 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 plus 4n minus 1 equals n times 2n plus 1. So I've got p sub n equals 3 plus 7 plus 11 plus dot 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 plus 4n minus 1 equals n to the 2n plus 1. I'm going to check for p sub 1, which means 4 times 1 minus 1 should equal 1 times 2 times 1 plus 1. 4 minus 1 is 3. 1, 2 plus 1 is 3. So I've validated p plus, or p to the first, or p sub 1. Then just change everything to k. 3 plus 7 plus 11 dot 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 plus 4k minus 1 equals k times 2k plus 1. And I'm going to check out p to sub k plus 1, which is the old plus a new one with k plus 1 in its place, and it equals k plus 1 times 2k plus 1 plus 1. So take a minute to write that down. I'm going to do this on the next screen. So my p sub k plus 1 equaled 3 plus 7 plus dot dot dot. Just for space sake, I'm going to k plus 1 minus 1. So this was one term, this went to that one. Equals k plus 1 times 2k plus 1 plus 1. So this old, my original p sub k was equal to k times 2k plus 1, and it's plus 4k plus 1 minus 1. And now it's just a matter of doing all of your algebra. Then this is 2k plus 2 plus 1. So 2k squared plus k plus 4k plus 4 minus 1 equals k plus 1 times 2k plus 3. I'm going to leave the right-hand side by itself. I'll just get this together and multiply it out, or FOIL it out. K squared plus 5k plus 3. And if I factor that, it comes out to 2k, k. And then I need a 3 and a 1, a plus and a plus. And that equals k plus 1 times 2k plus 3. So k plus 1 times 2k plus 3 is the same thing as k plus 3 times 2k plus 1. K plus 1 times 2k plus 3. And I've proved that one.